question 634 on page 322. This is a very interesting question. It is about computer monitors. And if one monitor, the average life will be 4,300 hours. And in order to ensure that the factory has got sufficient monitors to work, they have also 2 backup monitors. So actually a set of monitors means 3 monitors. And the question asks about that if the mean, this is the mu of the population, is 4,300 hours and standard deviation is 730 hours. And what will be the probability that this given set of monitors will last at least 13,000 hours? So actually your sample size is a set of monitors, means 3 monitors. One is the primary monitor and the other 2 is the backup monitors. So if you know the population standard deviation, you know the sample size, and then you can get your standard error. And your standard error comes from population standard deviation divided by the square root of your sample size. So 730 divided by the square root of 3. And then you get your standard error 421.5. After that, you want to get the z-score. And the z-score comes from the first, visualize it. You see that for each monitor, the mean average hour is 4,300 for the population. And for this one, at least one set is 3 monitors, at least 13,000. Means for each one monitor, means 13,000 needs to be divided by 3. And then you get 4,333.33. So that will be somewhere here. At least this means larger than this number. At least 4,333.33 means larger than this number. So we want to know the probability of this part. And our z-score comes from 4,333.33 minus the population mean, 4,300, and divided by the standard error. We have just got it, 421.5. And then you get your z-score is 0.08. If you check the table A1, you can know the probability is 0.0319. And that means 3.19% of the data lies between this and the mean. And your last step is to use 0.5 to minus 0.0319. So your final answer is 0.4681, means this part. This is your final answer.